Welcome to Tutorial 11, Model Customization in GPSX. No wastewater treatment software can be made in a general enough way to automatically handle all wastewater treatment plants and variables. This is why GPSX offers a built-in customization tool allowing users to customize their model layout as required. This is an advanced feature that requires the use of the simulation language Axle. In this tutorial, we will be adding two equations to the software to calculate the specific oxygen uptake rate. One equation will assume ideal oxygen uptake rate, while the other looks at a simulated measurement noise. The goal of this tutorial is to show users the steps involved with implementing your own custom code to create custom variables and use them as if they were included in the GPSX default layout. Begin by opening the layout that was built in Tutorial 2. Save the layout under a new name. Switch to modeling mode. Change the influent flow type to sinusoidal by right-clicking on the influent object and selecting Flow, Flow Data, and changing the flow type variable. Next, adjust the reactor's operational parameters. Right-click on the reactor and select Input Parameters, Operational. Change the Specify Oxygen Transfer By variable to entering airflow and the total airflow into the aeration tank variable to 30,000 meters cubed per day. Save the layout. Switch to simulation mode. Create a new Output Graph tab by pressing the New Graph tab button. Right-click on the influent object and select Output Variables, Flow. Drag the flow variable to a new Output tab. Next, right-click on the reactor and select Output Variables, Internal Variables. Press the ellipses button next to the actual oxygen uptake rate variable and drag the first element in the array to the same output graph. Press the Output Graph Properties button. Rename the graph to Influent Flow and OUR. Unlock the minimum and maximum fields. Set the limits of the flow axes to 0 and 10,000 meters cubed per day. Set the limits of the OUR axis to 250 and 1,500 milligrams of O2 per liter days. Run a 10-day steady-state simulation. Save the layout. We will now create custom user-defined variables to add to our graph. Switch to modeling mode. We will be adding 4 custom variables using Axle code. Open the Layout drop-down menu on the main toolbar and select General Data, User Files, Macros. This will open a file window where you can enter custom Axle code. This file is generated when you save the layout for the first time. The file has several distinct sections separated by asterisks. The initial section contains calculations that will be performed before the dynamic simulation begins. The derivative section contains calculations that will be performed at every time step. The dynamic and discrete section contains calculations that will occur at every communication interval. Finally, the terminal section contains calculations that will be performed at the end of a simulation. We will be adding code to the derivative section of the macro file. Add the following code to the macro file. Note that lines starting with an exclamation mark are comments. The other lines of code we are adding create 4 new variables: noise, OUR with noise, sour1, and sour2. The noise variable is a normally distributed random signal. To simulate the measurement noise, we are using the Axle command Gauss. The OUR with noise variable adds the noise to our OUR. The sour1 and sour2 variables represent the specific OUR with and without noise. The mean and standard deviation are constants that we will specify later. Note that two GPSX cryptic variable names are used in this code. The cryptic variable names used in these calculations are OURLMLSS1 and VSSLMLSS1. These correspond to the actual oxygen uptake rate in the mixed liquor volatile solids in reactor and are both taken from the first tank in the plug flow reactor. Remember that you can view a variable's cryptic variable name by hovering the mouse cursor over it and viewing the tooltip. Click Accept in the macro window to save these changes. Note that GPSX will save the changes to the macro file as a .usr file in the current working directory with the same name as the layout. You can open the file and edit it in an external text editor if you prefer. Next, we'll add custom input variables to the GPSX interface. Open the Layout drop-down menu on the main toolbar and select General Data, User Files, Constants. This will open another file window containing Axle code. Code added to this file allows you to create custom input variables on the same type of input forms as the other variables in GPSX. We will first update the menu and header item found at the top of the file. These are responsible for defining the menus and object groupings of the variables. The next two lines begin with the word constant, signifying that the variables are an Axle constant. Following this indication are the cryptic name, value, label, and unit. This code will be saved in the .con file in the model directory. Like the user file, this file will have the same name as the layout and can be edited in an external text editor if preferred. Click Accept in the constant window to save the changes. GPSX will prompt you to reload the layout. Reload the layout and click Yes when prompted to save. When reloaded, GPSX will read in your user-defined constants and create the menus associated with them. To see the user-defined constants, open the Layout drop-down menu on the main toolbar and navigate to General Data, User, Input Parameters, Noise Variables. Finally, we'll add some custom output variables to the simulation. To do this, select the Layout drop-down menu on the main toolbar and select General Data, User Files, Output Variables. This will open the Output Variables Axle file where you can set up output variables in a similar form to the constants with a few notable exceptions. In the user outputs file, the display keyword is used instead of the constant keyword. Also, a value is not given for the display variables as it will be calculated by GPSX. The custom code can be accessed in the .var file in the same directory as the layout. This code file can also be opened and edited in an external text editor if you prefer. Click Accept to save the changes to the output file, and GPSX will once again prompt you to reload the layout. Reload and save the model. You can see the user-defined output variables in GPSX by opening the Layout drop-down menu and going to General Data, User, Output Variables. There will be two new options available. Switch to Simulation Mode. We will now create input controllers for both of our custom input variables. These variables are found under Layout, General Data, User, Input Parameters, Noise Variables. Drag both variables to the Input Controller section. Open the Input Controller Properties window to change the limits of our controllers. Set the limits of both variables to 0 and 100. We will now create output graphs with our user-defined output variables. To find these variables, navigate to Layout, General Data, User, Output Variables, Uptake Variables. Make room on our Output tab for a new output graph. Add the OUR with noise variable to the graph that we created earlier in the tutorial. Create a new output graph with our two user-defined SOUR variables. Open the output graph properties for both graphs. Set the limits of our OUR with noise axes to 250 and 1500. Rename the plot with the SOUR variables to SOUR with and without noise. Auto-arrange the graphs and run a 10-day steady-state simulation. Run additional simulations varying the noise parameter using the input controllers to see the effect it has on the output graphs. Save the layout. You have now completed Tutorial 11 in the GPSX tutorial series. You should now be familiar with how to set up user files to add custom code to the GPSX layout.